Hello, pre-calc students. Today we are going to do 2.7 Part 1 notes, polynomial and rational inequalities. We're going to look at two ways to do this. The first way is what we're going to talk about today, and then we will do the other way next time. So right now we're going to do number lines, and then we'll do graphically next, which will be Wednesday. Okay, so let's just start off here with an example. Or no, never mind, we're going to do the steps first. Okay, so steps to solving inequalities algebraically. First, solve to find critical values. So critical values are any zeros or restrictions. So remember, restrictions are those numbers that make your denominator 0. Or like we saw when we graphed rationals, the vertical asymptotes. Those are your restrictions. Then we'll place these critical values in order on a number line, and then test values to determine a solution set. So this is going to be very similar to how we do domain. Okay, now let's look at an example. Okay, so this example, this is a polynomial. It's not rational. There's not a denominator. And it's a cubic. So what I'm going to want to do is find the zeros of this cubic. Well, to find zeros of a polynomial, we want to factor. If possible. You know, we learned in the beginning of this chapter that if it doesn't factor, we can always use the graph to find a zero, or be given a zero and do synthetic division. But all of this here, this is going to be on the no calculator part. So if we're going to find the zeros here, then you would be able to factor it. Okay, so I need it equal to 0, or in this case, I need just one side to be 0. I want my leading coefficient to stay positive, so I'm going to move this 4x over. And then I'm also going to move that 4, but I don't want to add it. I want to subtract it. Okay, so then I have x cubed plus x squared minus 4x minus 4 greater than 0. So I want to find the values of this polynomial that are greater than 0. Okay, so typically if we factor 4 terms, we do this by grouping. Okay, so I'm going to group the first 2 terms, group the second 2, and technically, you know, I'm adding there in between. Okay, the GCF of the first term, x squared, so I get x plus 1. And then the GCF of the second group is negative 4, and that's also x plus 1. That's how I know that grouping works, is when I get the same thing in the group. Then what I actually do is factor out that group, so x plus 1, and then I'm left with x squared minus 4, which then factors to x plus 2, x minus 2. Okay. So I can find my critical values, my zeros of this polynomial. So that's what I'm going to do first. So CV for critical values. So I have negative 1, negative 2, and 2. All right, I'm going to put these on a number line in order. So I have negative 2, negative 1, 2. Okay, I am solving the inequality greater than 0. Okay, the first thing I want to test are my critical values. So my critical values in this case are all the zeros. All right, so knowing that, negative 1 makes the polynomial 0, negative 2 makes the polynomial 0, and 2 makes the polynomial 0. So is 0 greater than 0? No. So at all of these critical values, I'm false. And which means on the number line that shows up like an open circle. Okay, now let's test each interval that we have. Okay, so I'm going to pick a number here that's less than -2. So if I plug a number in that's less than -2, I'm going to plug it in to this factored form. So for example, -3. So you can actually plug in -3 and work this out if you want. Or let's just think about signs, positive and negative. So if I plug in -3, -3, so I'm plugging it again right here, -3 plus 1, well, that's negative. -3 plus 2, that's negative. And then -3 minus 2, that's also negative. So a negative times a negative times a negative is negative. Okay. And then is a negative number greater than 0? No. So this is false. Okay. So I'm going to do that for each interval that this number line is broken up to. Okay. So next I'm going to go here. So between -2 and -1, that's like -1.5, let's say. Okay, so -1.5 plus 1, so I come back to this. -1.5 plus 1, and that's negative. -1.5 plus 2, that's positive. -1.5 minus 2, that's negative. A negative times a positive times a negative is positive. So is a positive number greater than 0? Yes, that's true. So I can shade here. Okay, now let's go here. Well, between -1 and 2, we can use 0. So 0 plus 1, positive. 0 plus 2, positive. 0 minus 2, negative. Positive times negative times positive times negative is negative. So false. And then finally, my final section, my final interval I need to test. Let's think of a number greater than 2, so 3. 3 plus 1 is positive. 3 plus 2, so again, I'm back here. 3 plus 1 is positive. 3 plus 2 is positive. 3 minus 2 is positive. A positive times a positive times a positive is positive. A positive number is greater than 0. So this is true, which means I can shade here. Okay, so again, without a calculator, this is really the easiest way to do it. My final step is to actually write our solution. So our solution is going to be written in interval notation, solving inequalities. That's how we typically write our solution. Our variable was x. So x is an element from -2 to -1. Since those are open circles, I need parentheses. And then from 2 to positive infinity. So the parts that are shaded on my number line. Okay. So we're going to do this again. One more example, and this time we'll look at a rational. Okay. So again, we need to identify our critical values, which are the zeros, and restrictions. Okay, so we know that the zeros of a rational function are the zeros of the numerator. Those are those x-intercepts, your zeros. So I need to factor the numerator. So I'm going to move this down a little bit here. So the first thing in the numerator I could do is factor out an x. So then it's x squared minus x minus 6. And then I can factor this. Feel free to pause it if you want to think about how this factors. but this is going to be minus 3 and plus 2. Okay. And then I also have a critical value because it's a restriction in the denominator. So denominators are restrictions where those asymptotes would be. This one's already set less than or equal to 0. I already have 0 on one side. And these rational ones will be like that. It doesn't have to be 0 though. If there were like a 1 there, then I'd be comparing everything to 1. If it's, less than or equal to 1, then it's true. If it's greater than or equal to, or greater than 1, then it would be false. Okay, I'm going to pop back here for just a second. Okay. All right, so our critical values. Well, I have the zeros, so the numerator, which would be 0, so 0, 3, negative 2, but then I have the critical value of my restriction, which I know my restriction is 1, positive 1. X can't be positive 1 because you cannot divide by 0. Okay, so I'm going to make a number line. Give us some more space here. And I'm going to put these in order, so negative 2, 0, 1, 3. But okay. And I am testing less than or equal to 0. And I'm going to actually write the factored form over here to the side, so then I don't have to keep looking up. So I'm plugging my values into here, into my rational function. Okay. So I'm going to do the positive negative thing, but I have some dividing here. The first thing I want to talk about are my actual critical values. So what's happening at these critical values? Are these going to be open circles or closed circles? All right, so at negative 2, at my zeros, which is these right here, then that's where the function equals 0. And since it's less than or equal to, then all of these can be included, these three values. So negative 2 were true. Okay, at 0 is true, and at 3 is true. So all of these are going to be closed circles. Okay, but 1 is not a 0. It's a restriction. And I already know from right here, x can't equal 1. If I try to plug in 1 to my function, then I would be dividing by 0, which is undefined. I can't do that. So this one is false. Remember that that's a vertical asymptote. So you can't have an x value at a vertical asymptote. So this is an open circle there. Okay. So I want to pick numbers from each region. Feel free to, after I do this first one, to go ahead and pause it and then try to work it out on your own and then go back and see if you get it right. Okay, so here I'm plugging in something like negative 3. So I'm plugging it into this right here for x. So if I plug in negative 3 for x, well, that's a negative. If I plug in negative 3 for x minus 3, that's a negative. And then negative 3 for x plus 2, that's a negative. And then negative 3 for x minus 1, that is also a negative. So a negative times a negative times a negative on the top, that's a negative. And a negative divided by a negative is positive. I want less than or equal to 0. So a positive number is not less than or equal to 0, so that's false. Okay, now, here. So again, if you want to pause it and then try to test the rest of your intervals on your own, that would be a good idea to check and see if you're doing this right. Okay, so I'm thinking about -1 here. So negative times negative times positive divided by a negative. So positive on top divided by a negative on bottom is a negative. Okay, a negative is less than or equal to 0, so that's true. So I'm shaded here. Okay, here, 0.5. Again, I'm going right into this function. So 0.5 is positive. So positive times negative is positive divided by a negative. Okay, a positive times a positive on top is negative. And negative divided by negative is positive. Okay, positive number is not less than or equal to 0, so that's false. So I don't shade there. Okay, and here. Now you'll get to the point where you won't have to really show all of this work. I like to see at least these first ones here, and then your true and false on your number line. But if you can do the rest of that part in your head, then that's fine. Okay, so between 1 and 3, I can plug in 2. So positive, negative, positive, divided by positive. So then a negative divided by a positive is a negative. So that is true because a negative number is less than or equal to 0. And so I'm shaded here. And then here, let's think about 4. So that's positive, 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 divided by positive. So that's going to be positive, which is false. It's not always necessarily every other one. Okay, so I want you to be careful with that and just don't automatically think that it's always every other one. Okay, so going back with the work I want to see, I obviously want to see your number line, I want to see the critical values. Then the first thing you should decide is open or close circle at those critical values. Now, my circles are closed here because these are the values that make the function equal to 0. So that's the equal to. That's the equal to part right here. The other parts that are shaded, these here, these are the less than part right here. Now remember, 1 was not a 0. 1 was a restriction. So restrictions can't ever be equal to. Those are going to have an open circle. Okay, so I want to see your number line. I want to see those critical values, and I'd like to see this first step here. And then, of course, don't forget to write your answer. Again, my variable that I'm using here is x. So I have the first shaded part, which is -2 to 0. Now, -2 and 0 both have closed circles. So in interval notation, that's a bracket. Okay, I have another place that's shaded, so union. And then I'm 1 to 3. Now 1 is a open circle, but 3 is closed. So I have parentheses at 1, bracket at 3. Okay. So thanks for listening. This homework is in Pearson 2.7 Part 1. Email me if you have any questions. Thank you.